Hello and welcome to TGIK live at the Heptio studios here in Seattle, Washington. How's everybody doing today? I am your host, Kris Nova, and today we're going to be talking about Falco and some dynamic auditing in Kubernetes. And it is Friday, and it's actually really good weather today here in Seattle. I always like to look at the mountain when I start TGIK because I can see Mount Rainier, Tahoma as I like to call it, right out the window here, and I like to tell Charlie hi before I start my videos. But yeah, we could see the mountain today, so it was really rad. So yeah, let's do hellos. I haven't seen everyone. It's been like weeks since I've done a TGIK. I've been off in Iceland. Joe took a rad vacation down to Hawaii. I'm back from Iceland. It was really cool. I took a bunch of fancy pictures with my new fancy camera, and we took a couple weeks off, but we're really excited to be back and like start a whole new year of TGIK here now that we're at VMware, which is still really exciting and still kind of like new and a shock to me to be like, oh yeah, we're VMware now. This is awesome. So yeah, let me pull up the chat here and see what folks are saying. Oh my gosh, every time I look at the chat after like doing my little intro bit or whatever, there's like a whole wall of text and I'm like, oh gosh, what are people saying? So yeah, let's see. Olav was our number one today. Good to see you, Olav. He says, Happy New Year and a happy year to everyone who observes other non-Gregorian calendars. Aliciano, good to see you again. Suresh, hey, joining from Hamburg. Okay, it looks like George is here at the Heptio account. George, thanks for helping us out. And also, George, good to see you again. I always feel like George and I have this special moment right before TGIK where like I'm only streaming to him, and so he gets like a private behind the scenes TGIK and like watches me brush my hair and get nervous. So anyway, George says, hi everyone, this is George. I'll be helping Kris today, and we'll get started in a few minutes. He says, welcome, we appreciate you joining us. Let's see, Hamid says, hi George, will you be sharing the agenda link after this session? Hamid also says, joining from Ireland, good to see you, Hamid. Mark, hi, I'm Mark Sten from SixStig, one of the lead engineers on Falco. Happy to answer any questions or help out if needed. Mark, I'm definitely going to be counting on you some today. I got most of the things kind of glued together, but there's still one or two spots that I haven't fully done an E2E test on. So we're just going to kind of do that live. So I might be leaning on you a little bit on the Falco side of things as we start hacking on getting auditing plugged into Falco and getting that whole thing set up. And then also, Mark, thanks again for helping me out the other day. Mark sat on the phone with me and gave me a little bit of Falco information, so good to see you. Heptio says, thanks for joining. Roy, happy Friday from Toronto. George says, as per usual, here's our notes. So we'll pull those notes up in a second. We can look at them together. Feel free to contribute if you want to contribute notes or if you want to add links or anything. Sometimes I go off on a tangent, and folks, it's handy if you like want to help me out and like drop a link in the notes for me so I don't have to stop the stream to like cut over and do it. So Walid, hi from Libya. Let's see, greetings from Braunschweig, Germany. I think I said that right. Mike says hello from New Jersey. Peter, happy Friday from San Diego. Dan, hello from New York City. Oh, I lost it. New York City. Pop, Marky Jackson Pop. And then Dan Papa Andrea, I think I said that right. It says Pop from Sistig. This is interesting, Dan. I was trying to find your last name, and I went on your Twitter, and it just said Pop, and I was like, I guess he just goes by Pop, so we're going to call him Pop. So anyway, good evening from London. Nadir, good to see you again. I'm going to try to do my best to imitate this. EO from Chicago. Brandon. Hello, Kris. Hello, Falco. Hi, Herman. Joe Rockland. Hi from Cincinnati. Gordon. Hi, Kris. Greetings from Houston. Let's see. We have CD AV Savix. I don't know. Hello from Santa Barbara. Bob, shout out from beautiful Hollywood, new LA meetup on Spinnaker launched last night. So I want to do a TGIK on Spinnaker. I've been thinking more and more about doing it, and I think it might be fun. So maybe I can ping you like after the fact, and you can tell me how the Spinnaker meetup was, and maybe give me some ideas for doing a TGIK on Spinnaker. Joy says, hello, Kris. Christoph says, hi from Dusseldorf, Germany. Let's see here. We have Rajat from Bangalore, India. We have somebody from Leipzig. Steve-O, I have no idea where that's from. Where in the world is Leipzig? Hello from Mexico. George or Jorge, I'm not sure because we have a George that goes by, that's spelled the same way. So sorry if I mispronounced your name. Hello from Cupertino. Nice ice climbing action lately. Where is Cupertino? I feel like that's... Oh, okay, so Cupertino is in California. I was like, wait a minute, is there like a Cupertino, Alaska or something? Because I thought you were suggesting there was good ice climbing there. But yeah, I've been on a big ice climbing kick lately with my fancy new ice climbing tattoo. And I think I'm actually going to go do some ice climbing tonight as soon as I get out of TGIK. So I'm pumped about that. And yeah, ice is nice. So yeah, ice climbing. Hello from localhost. So I'm assuming that Injin is here in Seattle. Christophe, hello from Paris. Cornelia Davis from Pivotal. Hi, nice to meet you, Cornelia, my new coworker/colleague. Waleed says, yes, please, Spinnaker with happy things. Dimitri, hello from London. And Maxim, hi from Russia. Okay, rad. Okay, so we got through all the hellos. I'm sure people will continue to say hello. I'll come back and do more hellos in a little bit. But let's just jump right in today and look at some of the what's new in Kubernetes this week. And George did a lot of these, so I'm going to be kind of looking at these live as folks at home are. So we're going to learn about them together, which is exciting. Okay, so let's see. Let's cut over to my screen and my face. And let's get all of this nice and buttoned up. Bam. Okay, cool. Oh, so by the way, we use this tool called Moom. I don't know if folks have heard of it on TGIK. And here's the little settings for it. And that's how I'm able to define precise window sizes on my screen here. So if I drug this over and it was off the screen and kind of ugly, if you notice, I don't ever try to move it up here and get it just right. We have hotkeys, so I just do Control O, which moves it up there, and then Control P, which resizes it. So at any time, I could have all these things out of the way, and bam and bam, it's all nice and neat and pretty again. So yeah, if you want to check out Moom, it's a cool tool that makes desktop management a lot easier. It's changed my life since I downloaded it. So that's the first tip of the day. Let's see what we got going on in Kubernetes. All right, let's scroll up. So first one, 2 big CVEs. So I think I read the one about the API server. So Jesse did a write-up on this. Let's see if we can find it. Oh yeah, so this is Jesse's. This isn't the email she sent. There's an email sent to KDev, the Kubernetes mailing list, which if you're not a member of that, you can just go to Kubernetes dev mailing list. Let's see if we can find it here. Subscribe to Kubernetes dev. So some people call this KDev. It's Kubernetes dev. This is the sort of let's see what we have here. Kubernetes developer and contributor discussion. This is just the main dumping ground for all of the stuff that goes on in Kubernetes dev. And this spans a pretty big audience. So if you ever have any really major Kubernetes questions or comments, or you really, really need some help, you're really stuck and nobody seems to know an answer, this is a really good place to send a message in a bottle and just hope for the best. It's pretty active, and if you subscribe to it, you can get a lot of interesting Kubernetes things in here. So anyway, there's a ton of these mailing lists for all the different SIGs. There's one for SIG AWS and one for SIG cluster lifecycle, and I think Jesse sent one out to the security SIG. So let's see if we can find Google group, Kubernetes security, bam. Yeah, I think this is it here. Kubernetes, no, this is announce. But either way, you can just look up here and you can change this little bit. And I think we can do Kubernetes SIG security. That might work, it might not. Anyway, let's go back and look at our link here that George gave us. So there's a bunch of SIG mailing lists if you want to go join those. And you can go to github.com/Kubernetes/community to see a list of all of them. So Jesse came in and said, hello, everyone. We have this new vulnerability that we detected, and then there's an explanation of what goes on here. I haven't really read this in detail, but I do know that it wasn't nearly as severe, I don't think, Jesse can tell you much better than I can, than the big one we had a few weeks ago. But just be aware of this, and these CVEs are, they happen, it's part of open source software. We're working hard to work on hardening our builds and testing and doing penetration testing. And I think the more of these that we have, the more serious the community is going to start taking these. So just be aware that there is an exercise of keeping up with this stuff and patching your Kubernetes clusters. So having a managed service, or having some tooling in place, or having some sort of subscription in place to help you when things like this happen are very helpful. So that's the first one, which affects the API server. And then the dashboard, I feel like just the dashboard in general is just basically a CVE. But this is another one that Jessie, I don't know if she found it or if she's just the one doing the write-up on it, but she does really good write-ups. She's a great author. I love the humor in a lot of her writing. So if you want to come and read more about these, come check it out. And I think there's a link to a PR here where you can actually go and see the add-ons that are affected in the CVE. So 2 really important CVEs, and then just being aware that this one is for version 1.10. So we're on 1.13 now. In fact, that Kubernetes dev mailing list I was just mentioning, I think I saw an email earlier today about 1.14. Again, we're already on a new version. I feel like I say that every TGIK, and I feel like I say that every TGIK. Okay, cool. So this is going to drive me nuts. Let's get rid of this. Kate's 1.13.2 is out. This is exciting because this is what we're going to be running today. Also, I have a bit of a cold, so at a few points in the episode, I'll probably stop and like drink some club soda or some water or some Diet Coke here. So just bear with me, especially if my voice starts to go out a little bit. I'm not sure if it's a cold or if it's just allergies, but yeah, it's been a little bit rough this week. So let's see what folks are saying in the chat before we talk about 1.13 here. We have hello from London, Russia. Leipzig is a town in the southeast Germany. Okay, cool. So that was a question I asked earlier. Bojanche, hello. Heptio says, here are the HackMD notes if you missed it. Tim says, watcha, and are we going to cover the new System D CVE as well? Hamid, no, I didn't know that there was a new System D CVE. Is that, I'm assuming by System D, you mean that's a CVD that afflicts System D only, which might trickle into being relevant in Kubernetes, but if there's a CVE in System D, like, you already have my attention. If you want to drop a link in the chat and ping me, or a link in the doc and then ping us in the chat once you have it there, we can take a look at it together. Lamatti, good to see you. Happy Friday. And Leonardo, hi from Brazil. Okay, cool. So back to 1.13. So we're running this today. It's a new version of Kubernetes. I almost said new episode of Kubernetes. It's a new version of Kubernetes. And like always, you can come in here and you can click on this and you can see the changelog here, 1.13. And then this is like the source of truth for everything that has changed in this release. And you can come through and you can see changes here. So I'm wondering, do we have audit in here at all? Dynamic audit configuration. Okay, cool. So this is the feature that we're actually going to be looking at today. And I'll talk a little bit about the wonderful time I had spinning up a 1.13.2 cluster in Amazon using KubeCon. I spent a lot of time today dialing in a kube config and getting everything up and working. So I'm probably going to PR that to KubeCon afterwards because I have not found another good example of 1.13 in Amazon that just kind of gets you off to the races with like a single command. So that was what I worked on today and some help with some folks internally to help me get it up and running. Anyway, dynamic audit configuration. I wish I could do a show of hands here. Actually, yeah, we can. Let's do like let's do a +1, or just say me, and say the word me in the chat. If you have heard of audit in Kubernetes before, or if you even have an idea of like what it means to like look at the audit logs or an audit stream in Kubernetes. The dynamic audit configuration is interesting because it basically allows you to turn on and off and configure this feature dynamically, meaning using a Kubernetes object, you're able to go in and actually configure a stream where you can point the audit logs or the audit stream to. And so the sort of bigger pattern here would be like this client-server model of the API server, the Kubernetes API server being the client actually in this case, and actually streaming up to a broader server. I think I said that right. I guess, well, no, because the API server would be pushing a stream, could still be considered the server. Okay, either way, there's two people with a connection and they're sending data back and forth. So anyway, looks like a handful of folks. Me, it sucked. George, me. Bismarck, me. Mike, me. Lamatti, me. Haha, what's up, Biz? So yeah, it looks like Bismarck goes by Biz. But yeah, Michael Ducey says, I added a link to the blog post in the notes, how to detect the dashboard CVE with Falco. Awesome, Michael. We can totally look into that as we start playing with Falco. And I'm kind of like, I've got Falco to the point where like I can do the generate events or whatever, but if we can try to like do something fun or exciting like that, that would be cool to demo live. So Michael, if you have any ideas as we get there, let me know and maybe you can walk me through some of them. So anyway, yeah, let's do a quick picture of dynamic auditing just to kind of help folks at home. So let's go to the dock camera, get a fresh new piece of paper here. So basically we have the Kubernetes API server. We'll draw that up here. We'll say this is the API server. And then, you know, as per usual with the API server, there's like this whole big cloud of clients over here that are interacting with it back and forth. And these are like, you know, Kubernetes users or like, you know, pods that are using the Kubernetes API. Now, tangentially to this, we have this new thing called an audit stream. So we're going to kind of draw an arrow coming out this way, and we're going to call this an audit stream. And this is another stream of data. And of course, we all know the API server after the CVE of last year has a lot more than just this single connection going on. There's actually a lot of connections going in and out of the API server, and it tries to do its best to manage those. But we're introducing a new one that we're calling the audit stream. And probably the easiest way of thinking of this audit stream is it could actually go and it could log to like a var log directory, and it's just a stream of audit events. So literally, you can set it up, and you can have different log levels, and you can set up policies for it, and just say like Kris Nova, the user came in and created a new pod, and we could have like an event for that, and we would be able to go and actually have that record of kind of who did what, and we could sort of start to piece together a story here. Now, what's cool is with dynamic auditing, I'm going to put the word dynamic up here. We're able to go in and define objects in Kubernetes called audit sync objects, and we'll look at those in a little bit. And we're able to actually point this to different like endpoints and actually use network traffic instead of writing to disk to actually send this audit stream to other things. Falco is one of the few projects out there that can actually absorb one of these audit streams. And you can point the audit stream at Falco, and then Falco will actually go in and able to make sense of that and do all the wonderful filtering that Falco does for us and let us know if anything seems suspect and we should check it out. So that's Kubernetes auditing. It tells you kind of who, what, when, where. You can write it to disk or you can point it to Falco. And with dynamic auditing, you can sort of do all that dynamically using Kubernetes objects. Let's see. Heptio, you can find Kate's talk on KubeCon on audit logging here. Bam! So there's another good link there. So anyway, that's dynamic auditing versus regular auditing. In the past, in order to set up an audit stream, you would have to go in and restart the API server, and it was like this manual process, and you kind of had to hard codes and stuff. And now we actually have these convenient objects, and there's this sort of reconciliation pattern that we see all over Kubernetes that will go and direct our audit stream for us based off of one or more audit syncs. Now this is a sync like a kitchen sink, like audit sync, not like a SYNC. Which, as I learned today, thanks to my good colleague Patrick, is actually a common term in big data, the word sync. So those are those things, and we'll be talking about audit syncs later. Just remember that it's sync like the kitchen sink and not like a synchronize. Okay, cool. So let's go back to our docs here. Okay, cool. So 1.13.2, we can get dynamic auditing, and there's a lot of other good changes here as well. And congrats to the release team and all the folks at Kubernetes, Patrick included, who worked really hard on this release. So also there's a new 1.14 draft schedule. So let's take a look here and close some of these other things. So it looks like Aaron came in and said there are some role-specific things we want to add a schedule. Let's go look at this. Looking at YAML, as per usual with Kubernetes, release 1.14. And then it looks like it's just some README files, and it's just got a schedule lined out here. So this is really interesting. You can come in and you sort of get a source of truth, and you can see what's going on for 1.14. I know the release team, they're all working really hard on hardening the stuff and sort of bringing light to it and bringing structure here. And it's amazing how far we've come since like the first few releases of Kubernetes I witnessed. I still remember to this day the first KubeCon I went at, like myself and a handful of other folks, like scrambling to get stuff done to cut a release during KubeCon. And there was like people in the hallway like hacking on it. And now we have like formal processes and entire teams and deadlines and schedules, and it's very formal. So it's exciting to see how far Kubernetes has come. So going back, Kate's 13.2 is out. We already saw that one. Draft schedule, not final. YMMV, I don't know what that is. And everybody knows how I feel about acronyms. So if you could spell that out explicitly as not to confuse me and other newcomers who don't necessarily have all of these acronyms memorized, it would be helpful. List of videos and slides from KubeCon. So I think we looked at this a little bit last year, but okay, so this is like a mapping of videos and slides. Let's see if my slides are on here. I'm curious. Kris Nova. Okay, so this is like one thing that is always frustrating is when you download the PowerPoint. Like I don't have PowerPoint on here, but we can see. I bet my fonts are going to be off. View, what? I don't know why this didn't work. Either way, you can come in and you can see. But yeah, there's a Google Slides link for mine and a handful of other folks as well. But if you want to come get the slides and look at the videos while you look at the slides, this could be a great learning resource. You can probably just even come here and just grep for words that you think are exciting. Like here's audit logs. So like here's Kate's audit logs, and here's audit in Kubernetes with Stefan, the future is here. So people talking about what we're talking about today, but there's videos and slides on them already, and they're probably much more rounded out than my 5 minutes of rambling here on TGIK. Let's see. It looks like people are saying stuff in the chat. So Michael says, nope, we already read that comment from Michael. Michael Ducey, your mileage may vary is why MMV. Best title for a talk ever. Just saying. Okay. Thanks. I'm going to say it. Pop. Thanks, Pop. So yeah, if you want to come in, grab for words that are exciting for you, like I bet we could even do security. Yeah, 17 talks. So if you want to learn more about Kubernetes security, come here. This is important because these are all recent videos too. Kubernetes moves quick, as you can see with how fast we do our releases. So staying caught up, there's a big exercise in staying caught up. And one of the things that is important is learning to share your findings. And that's one of the reasons why TGIK has been so successful, is because in the hour and a half, or if you speed up the time, the 45 minutes, that I teach or show folks at home what some tools and some lessons I learned, it's actually a little bit less time than it would be for folks to learn that on their own. So these talks are really good because they sort of like speed things up for you, and you're able to learn a lot in a little bit of amount of time. So that is helpful as well. So going back, let's see, another list of videos and slides from KubeCon. Okay, so we have another one. Oh, this one has emojis. Sorry, I already like this one more. And it looks like there's like a README file for each one of these. So this is helpful as well, so if you want to go check those out. Other software releases. Weave Flux 1.19 is out. Heptio Arc is out. So Weave Flux, we've talked about this a little bit in the past. This is brought to us by our friends at Weave, and we can go out to the main repo here. And it's basically the GitOps Kubernetes operator. For folks at home who don't know what GitOps is, it's basically using Git as a data store, and then there's this whole methodology of using Git as your source of truth and building out tooling around it as well, so that events that would happen in a normal Git workflow, like pushing or pull requests or merging, those can trigger events, and we can actually have interesting and exciting things happen because of the guarantees that Git, the versioning tool, gives us. So that's GitOps. It's the operations built around the Git versioning tool. And this is just an operator that runs in Kubernetes that reconciles a lot of these things for us based on these Git events. And actually, I think already this year, I've already written a Git events operator just for an arbitrary thing I'm working on for my Fosden talk. It's later this month / next month that is going to do some cool stuff, and it's going to react from Git. So this is handy, and it's actually really powerful once you get into it. So make sure you check out Flux, and hats off to the folks at Weave for continuing to drive releases. That's really rad. Okay, so Heptio Arc 10.1 is out. Hi everyone, we've released Heptio Arc version 0.10.1 with the following changes. We fixed Minio, there's a debug and install link, we have pod restore action, we have AWS signatures, fix the new line output, update to go, update our change logs, and added pprof support for the Arc server, and remove default token from all service accounts. Okay, so it looks like some security improvements and some other house cleaning, and then driving some more powerful features for Arc, which is everybody's favorite Kubernetes backup disaster and recovery tool. Also, at one point, we were talking about renaming Arc. I wonder what happened with that, if we're going to be doing that or not. But I think at one point we talked about renaming it, and it would be exciting to see which of those names. Actually, let's pull this up really quick. GitHub Arc rename. Let's see what happened with the issue here. I'm kind of curious which one won, or if one has won yet. There was a ton of comments in here. Steve Kris closed this 2 days ago. Okay, I have no idea. I'll have to follow up with the folks at Arc to see what happened here, but it looks like the issue's closed now. Cool, so we can get rid of this. And let's go back to our episode here. Okay, so here's the systemd CVE, but let's first look at Crossplane. What is Crossplane? An open source multi-cloud control plane. Oh, a diagram. I love a good diagram. Where's our one-sentence description at the top? Let's see if we have anything here. Crossplane is an open source multi-cloud control plane. That's a really good first sentence, but what does that mean? It introduces workload and resource abstractions on top of existing managed services that enable a high degree of workload portability across cloud providers. Okay, I think I'm not sure if we looked at this one or a similar one, but this graph is starting to look familiar. And this just looks like it's a way of mapping arbitrary services based on different clouds and sort of providing a standardized interface for that so that users can come in and interact with them and sort of be liberated from the underlying cloud. And that's sort of what that multi-cloud control plane sort of means concretely. Okay, so Crossplane, check it out. Siga Apps wants to remind people about API deprecations. What's going on here? Clean up what this PR is and why we need it. Switch client and test usage to apps v1. Okay, yeah, so the Kubernetes API, there's some interesting nomenclature around how we name our API versions, and at some point it is going to make sense to deprecate older versions of the API. So SIG cluster lifecycle has done a really good job of kubeadmin about providing tooling that will do the translation from one API version to the other. I actually will talk about that in a little bit when we talk about how we got our 1.13.2 cluster up and running. But the Kubernetes API is evolving, and as you start to write objects and express your applications and your configurations in the form of these objects, the Kubernetes community could grow, and those objects can then later become outdated or ultimately deprecated if you're not careful. So there is an exercise of sort of keeping up with that and keeping your objects tidy, and especially keeping them defined in the most recent version possible. So this is a good reminder that Kubernetes does have backwards compatibility guarantees, but doesn't always necessarily keep them around forever. Okay, so next up, not all distros affected. Check with your distro vendor, but let's look at the systemd CVE. So systemd, for folks at home, it's a Linux level program that's pretty fundamental to a handful, most I would say nowadays, Linux operating systems that you can go and download. And I don't want to undermine it, but basically it's a way for you to define a service that should be running. And there's another service called systemd that actually goes and makes sure those services are running. And it provides this common interface where you can represent all these different services, and you can start them and stop them and get logs and inspect them and do a handful of other things as well. It's sort of the newer version of the init system for the older Linux folks at home. If you've ever done like the init stuff or written a skeleton file in like etc init.d or anything like that, systemd is just like the new hotness that sort of solves that same problem. Let's see what folks are saying in the chat. Just saying Falco slides are there as well, +1 for new Heptio arc. KubeCon 2019 closes soon, January 18th. Stevo, yes, that's a great reminder. I got some CFPs I'm going to be working on maybe this weekend, maybe a little bit next week. But yeah, the KubeCon CFP is closing fast for Europe. I feel like we just got done with KubeCon North America, and we're already closing CFPs for KubeCon EU. So if you want some help, feel free to ping me. If I can't look at it, I can probably try to hook you up with somebody else who can look at your talk and give you some feedback. And then if you want to submit a CFP, now is the time. Don't be shy. Feel free to start submitting CFPs if you're interested. Like, the worst that's going to happen is somebody's going to say no, but you're at least going to get your name out there, and you're going to start getting in the habit of submitting CFPs. As somebody who does a lot of professional public speaking, I would say like my going rate is like 50-50. I submit for all kinds of conferences, and I don't always get them. And there's been conferences that I've talked at, 3, 4, 5 times in the past, and randomly I just don't get selected. So like it's totally normal. It doesn't matter how famous or unfamous you are. A good CFP is a good CFP. Most conferences won't even show the name or the gender of the person who wrote the CFP. So you're totally graded on scholarly merit and nothing more than that. So let's see. Herman says there was a systemd exploit. Saw something lately. Please update people. And Bergdis says QCon. And I think her name is Icelandic, so I've been working on my Icelandic. Let's see if I can say this. Bergdis Northro. I think so, and I think it just means Bergdis of the North, maybe Berg of the North? Something north. Unsure what that means, though. But yeah, so here's the CFE. Let's see what's going on here. We discovered 3 vulnerabilities in systemd journal D, 2 memory corruptions, an information leak, and out-of-bounds read. Okay, so it looks like there's some memory leaking going on here, and when there's memory leak, there's usually room for a little bit more malicious behavior that folks can take advantage of if that's something they're interested in doing. We developed an exploit CVE that obtains a local root shell in 10 minutes on i386. Okay, so with the memory link, they were able to actually gain a root shell. So this is fairly serious. If somebody is able to build a root shell out of a memory link with systemd, you're able to go in there and basically have root on the system. So that's a little bit scary. Every time you have a memory link, you're able to sort of build a new system inside of it if you know what you're doing. And if that's running in the root namespace, then you're pretty much getting root. So yeah, you're definitely going to want to upgrade systemd in your systems. And that's something you can talk to your friendly Linux administrators about, and I'm sure they can help you with that as well. So I would say fairly serious CVE here on systemd for folks at home. Okay, so let's close this, and let's start talking Falco and dynamic auditing. So I think, where do we want to start? Do we want to start with dynamic auditing and talking about that, or do we want to start with Falco? Let's start with getting 1.13 up and running, then let's talk about Falco, and then let's try to talk about dynamic auditing and glue everything together. Bergdis says, pretty good, last name means Northern Valley. Okay, so I got the north part right. I'm getting close. And then in the fourth character of her name, I think it's F. I want to say ETH. And that makes a sound. So that's how I got that interesting pronunciation there. Okay, so anyway, let's look at getting our 1.13 cluster up and running. So let's jump in my terminal here. So if we do a kgit nodes, first we can see that, poof, I've already done all the hard work, and I can move forward and talk about Falco and things now, but this is really important for folks at home. If you are actually trying to run a 1.13 cluster, it's not necessarily as easy as you think it is. And if you want to run Falco, you can't use something like Kubernetes and Docker, because the way Falco works, you're going to have to basically run on an authentic Linux system so that we can do the dynamic kernel module loading. And we'll get into that a little bit later. But anyway, in order for us to build our 1.13 cluster, we'll be pretty quick here. I'm going to PR this to the TGIK repo after the episode, but in case we have any more notes, I'm just going to add them here. But here in episode 61, we have a lot of files that are about to get pushed up to the TGIK repo for folks at home to look at. And then here in KubeCon, we can see we have 2 custom bootstrap scripts. So these 2 bootstrap scripts are what actually run with Cloud init to get our cluster up and running. And the exciting one here is master.sh. So we come in here and we can see it's like if you looked at a KubeCon bootstrap script, this thing looks super familiar. But the exciting part here is this kubeadmin-config.yaml. This is substantially bigger than our last one. I think the last one was only like 11 or 12 lines, and this thing's well over 100 lines long. And this defines all kinds of interesting kubeadmin fields and configuration. And then you can see here we inject some variables based on our system at runtime, like what's its public IP, what's its host name, what's its private IP, so that we can do various things along the way. And then you see up here at the top we define 1.13.2. Now the exciting part here, if you want to use Kubernetes dynamic auditing, or any auditing for that matter, you're going to have to change some of the Kubernetes API server flags. So in order to do that, if you're using kubeadmin, there is a really handy dandy, let's see, I think let's look for audit in here. Here we go. Handy dandy extra args thing here. And this will actually define the key value pair for a flag. So like, what would normally be -- cloud provider AWS, and then other commands here, now turns into this YAML key cloud provider value AWS. And you can do these for all of the Kubernetes API server flags here. So these bottom 3 are the ones that we had to enable for Kubernetes dynamic auditing. I think they're in the docs, but if you just want to use this, feel free to come in and grab these, or even steal this kubeconfig or this whole shell script file here if you want to get Kubernetes up and running with the dynamic auditing flags turned on. So looking at our Kubernetes cluster, we can do, I have this command here called kdump, and basically I just do this. I do alias kdump is equal to kubectl get all -- all namespaces. If this isn't in your bash RC, it totally should be, because it makes exploring Kubernetes way easier, because you can just use grep instead of typing out these long-winded commands like git pods -- filter this, that, and the other. You can just do kdump, which shows you literally everything in your Kubernetes cluster in one view. And from there, you can like grep for things. Like I want to see everything that's running in the kubesystem namespace, so let's just grep for kubesystem. And there's everything running in the kubesystem namespace. Okay, so anyway, we're going to do this, and we're going to grep for default, and we're going to show folks that we shouldn't have anything running. Okay, so we have this one service Kubernetes running here in our default namespace. That's expected. That comes with our cluster, so that's not really doing anything. But we don't really have anything else defined. So we have basically an empty default namespace. So let's talk about getting, Falco. My mind just went blank. I was like, what is this tool called? Getting Falco up and running in Kubernetes. So I have some documentation here at the bottom that's going to talk about how to install Falco if you want to kind of fly through this part, but we're actually going to go and we're going to pull up the Falco docs and start looking at the various ways we can install this in Kubernetes. So we can go to github.com/Falco security/Falco, and we'll just go here and we're just going to check out the GitHub repo. Lisiano says CM secrets and ingresses at least are not shown that way. Lisiano brings up a good point. So there are a few outliers, but usually if you're debugging and doing like demos like I am, those are things that, if you're going to get a secret, like you need to pipe it to base 64 and stuff anyway. So I don't really want to see those there anyway, so it actually kind of works out well for me. But thank you, Elisiano. And for folks at home, CM means config map, which is just an arbitrary key value pair thing that you can do to configure various parts of Kubernetes, and read that from other resources later. So anyway, here it is. Here is the Falco GitHub repository. Let's look at our first sentence here. Falco is a behavioral activity monitor designed to detect anomalous activity in your applications. So yeah, knocking it out of the park with that really solid first sentence. And it talks about how it's powered by Sysdig's system call capture interface. And Falco lets you continuously monitor and detect container, application, host, and network activity all in one place from one data source with one set of rules. Okay, so as I was on the phone with friends at Sysdig who wrote Falco, they said, I think it was Matt who said he had a really great analogy, which was basically Sysdig, which is the core of Falco. Let's pull this up here and see if we can actually find. Yeah, so here's the Sysdig repo. So this is basically what he said was this is the TCP dump or Wireshark of syscalls. So this basically takes a syscall that anything is making on your system, pulls it in, and then adds some like decoration around that, and then actually can send that outwards, and we can use that for various things. And that gives us tremendous insight into what our applications are doing, and gives us an ability to audit them and do things like expand on this stream, like what we've done here with Falco, and actually write rule engines around like various things that we could detect and then trigger on these detection things. And that's where the behavioral part comes in, where you're actually able to go and say like, okay, normally on a given day or a given section of time, we would expect like these syscalls to be sort of like discovered, or we would normally see this, but all of a sudden we started detecting these really weird other syscalls we don't normally see, and that's a really great way of saying something's probably going wrong. Maybe we have some malicious activity, maybe there was a bad deploy, maybe somebody's in our cluster that we don't know about, and this gives us an ability to sort of capture all those. The beauty of this, though, is because it's all coming from the kernel, you know that that's the source of truth, and that's the most fundamental load level you're getting to. So if you want to monitor the whole stack, sort of the idea here is you break everything down into its most fundamental pieces, which of course are syscalls, monitor those, and then that can start to piece together a story further upstream as you go. Because no matter where you're running on the stack, it's all ultimately going to get translated to syscalls anyway, which is pretty clever, and I think offers a lot of value to folks who are trying to learn about things that are going on in their systems. So thanks to Sysdig for building that, and then Falco on top of that for taking it a step further and giving us this really cool rule engine on top of it. Okay, so keep me honest. I want to make sure I said all that right. And I want to talk a little bit about how Sysdig and how Falco actually interact with the kernel, because this was exciting to learn as well. So I think here is the kernel module source code. So this morning I was like drinking coffee and I was coming through here and I like couldn't stop reading these C files because it was actually really pretty C code, and I haven't actually seen C code documented this well in quite some time. So it was nice to come in and actually see this. I think the most exciting one here is our main.c. And you can come in, you can see this is a huge file with a ton of contributors on it, but this is actually a kernel module that is loaded dynamically using DKMS, Dynamic Kernel Module, I forget the S stands for. Let's look this up really quick. DKMS, Linux. Support, Dynamic Kernel Module support. Dan Papa said, nailed it. Mark Stems has great description so far. Okay, so DKMS allows, so I guess in order to talk about how DKMS is important, let's talk about the days before we had DKMS. So once upon a time, when you wanted to add some functionality to your kernel, you wanted to like make an improvement, introduce a feature, install some new piece of something that was important to you or your company, you would effectively have to either recompile your kernel or restart your computer. We all remember those days of like, you may now restart your computer now because we loaded some change and your computer's not going to recognize the new change until it gets restarted. So folks were getting frustrated with this, and it was very annoying, especially for kernel developers who are working on building this over and over and over again, and they want to continually run it. So that's where DKMS came in and said, okay, let's figure out a way to load these things dynamically. It's actually pretty complicated because the entire kernel is basically an abstraction on your hardware and how you interact with all your peripherals. So loading things dynamically is actually really complicated, but DKMS gives us a clean interface for that. So how we're able to actually come in and load Sysdig and Falco is pretty cool. And if we later, once we deploy Falco, we'll actually look at the logs and you can see it doing the DKMS step where it'll come in and it'll say, okay, is my personal kernel module installed? No, it's not. Let's go and install this kernel module. Okay, now I can start reading syscalls, which at first you're like, whoa, wait a minute. You're installing this kernel module and it's just going to start messing with my syscalls. But if you think about it, all we're really doing is reading your syscalls, and we're not actually able to go and execute any of those. So it's kind of a read-only way of just parsing them and then gaining other arbitrary information that's going on in the system and mapping that to the timing of the syscall event as well. Omar said, do not forget to breathe. I get excited about the kernel. I'm really sorry. Yeah, let me take a break here. Also, the fact that like I'm super stuffed up. I'm like, and then the kernel, and then this, and then that. Okay, cool. So anyway, syscalls are exciting, DKMS is exciting, and that is how we're able to load Falco dynamically. Syscalls, let's try to keep it appropriate, please, Barry. So anyway, thanks to our friends. Okay, where were we? Here. So, and there's a link to DKMS here as well. Dynamic kernel module support. So this is the Wikipedia article if you want to kind of read about it. Okay, cool. So let's get Falco up and running. So if you come through and you read through here, it kind of talks about like what kind of behaviors can Falco detect. A shell running inside of a container. This will probably be the first one we demonstrate. And there's a handful of other ones here, like unexpected read of a sensitive file. So every time you do a read on a Unix-like file system, there's a syscall called read that is basically how you would tell the kernel, please go read this like piece of data from an underlying file store or some sort of volume underneath and return that data to me, and we're able to actually intercept that along the way. You can see a non-device file is written to dev, so device files are a special type of file in Unix or Linux-like operating systems, and a standard system binary like ls makes an outbound network connection. So a standard system binary like ls, which is a very simple tool, well, it feels simple once you interact with it, but it's probably not very simple to write. If you've ever tried to write an ls before, it's actually pretty complicated. But it makes an outbound network connection. So this is a great example of like somebody putting in a backdoor into your system. It's very common to take like a tool like ls or something that you may not even use very often. And if you do gain access to somebody's computer and then replacing it with a tool that looks, feels, and behaves exactly the same, but also has some secret other functionality that you may not be aware of, that perhaps makes some sort of like outbound network call. Maybe once a week, once a year or something, and it just sends a bunch of important or possibly vulnerable information out to some malicious third-party user. So this is a real common practice, and this is sort of like where the Trojan horse story comes from, of like getting a piece of software that you think is safe, somebody comes in and swaps it out when you're not looking or something, and then they can actually go and do malicious things later. So this is really cool that we can start to detect things like this with Falco. Okay, so we come here into the integrations directory in Falco, and you can see we have a couple of different things we can install here. The one that we're going to be installing today is called Kates using daemon set. So we come in here and we have this README here, and this is going to talk about getting Falco up and running and then also connecting it to Slack, which I don't have a really good, I don't have a root on any of our Slack servers, so I don't think I'll be able to connect it to Slack today. But if you have a Slack server you can play with, it's pretty easy here. As we go through the docs, I'll mention it, and you can figure out how to connect Falco up to your Slack server so that if something like malicious does happen, or if there's some sort of weird anomaly in your system, you'll get a friendly Slack message that's like, hey, by the way, I don't know if you noticed this, but the LS program is like sending all your secrets out to this like weird address on the other side of the world. You might want to go check that out. So, example, daemon sets using sysdig. So we're going to do Kates with RBAC, and we're going to try to look at these resources as we go. So what we want to do is we want to make sure we clone our directory, or clone our repo, and then move into that directory. So I should already have this thing checked out. Go source github.com/Falco security/Falco, and then of course you can see we can go into integrations here and Kates using daemon set. Okay, cool. So this is where we are. So if you go back here to the TGIK repo, you can see that I've kind of pulled a lot of these configuration bits out, moved them into the TGIK repo, and tweaked them a little bit so that we're actually able to do some cool things today. So we're going to go back to github.com/Heptio/TGIK/episodes 061. And you can see here we have Kates with RBAC, just like we had here. Or Kates with RBAC here. And I've just done some of the steps for us, so we're going to be using this. So let's see. Dan says, any webhook can be used for notifications. We have a workflow in our commercial tool, Sysdig Secure, which uses OSS Falco as a basis, rules-wise. Okay, thanks for pointing that out. I really like calling you Pop. I'm just going to keep calling you Pop. And like, can we just change your name to like all caps Pop? Because this is a lot of fun now. So in here, if we go to Kates with RBAC, you can see we have a lot of interesting things already created for us. And most of these are just copied over from the repo. I'm just keeping everything in one place so that our README is nice and easy for folks at home if they want to go through the README steps that we have in the TGIK README file there for episode 61. Okay, so first things first. Let's see what the docs say we do first. Integrations. Kate's using daemon set with RBAC. Oh, that's just the directory. Okay, so first things first, deploying Kubernetes with RBAC enabled. kubectl create -f, Kate's with RBAC, falco account.yaml. So this should be all of our RBAC rules here. So let's cat this out and take a look at it. Falco account.yaml. So that starts here. So we have a service account named Falco account. We have a really basic cluster role. Let's see what the cluster role can do. It can access the extensions API group. It can access nodes, namespaces, pods, replication controller, services, events, and config maps. And we can do git list and watch. So we basically have read only on those. Non-resource URLs, we can get health Z and anything under health Z, and we can do git on those as well. So pretty basic cluster role here. And of course, we're going to map that back up to our Falco account cluster role using our handy dandy cluster role binding. And remember, we talked about these a few episodes ago. Role bindings and cluster role bindings are basically like the XREF or bridge tables of Kubernetes RBAC rules, and they just allow you to map various roles to various accounts or users. So that's handy. So we're doing cluster roles here, which have slightly a broader scope than just regular roles. So you can either do a cluster role or a role, and cluster roles give you access to cluster level primitives like node information that you wouldn't be able to get with just a role which is tied to a specific namespace. So this is interesting. So we're able to actually span a little bit more using this RBAC setup with Falco here. So let's see what the docs say to do next. Okay, so next we want to copy these Falco YAML rules into this directory called Falco config, and then we're going to actually go and look at these. So this is where I'm going to be kind of counting on our friends at Sysdig to talk about these rules and kind of why they're important, and maybe we can find some documentation on it too. So back here, let's go into our Falco config, and let's cat out falco.yaml and start here. I have a feeling this is, no, it's not that big. Let's see, where do we start? Here. Okay, so we cat out falco.yaml. Oh, no, wait, that's our account. Here we go. Starts here. Okay, so commentary, rules file. Okay, so we have etc falco rules local.yaml, rules.d, JSON output. So this just basically, to me, looks like a configuration file for a service. And I'm assuming that this is going to be our config that we're telling Falco to run with. So Falco, this is a really good point why we're on the topic here. Falco doesn't have to run in Kubernetes. We're running it in Kubernetes today because they've done a lot of work with the audit stream so that we can do some exciting things with triggering on audit events. But you can run Falco on pretty much any Linux system, or you can even run Falco in a container. And it runs just like a Linux service, which is where we get this configuration file from. And you can come through and you can define various configuration bits for the Falco service. Now, a lot of the Kubernetes YAML that we're getting ready to look at is going to bundle all of this up and make some assumptions for us so that we can sort of easily deploy it to Kubernetes, and it'll start monitoring our host system syscalls. So this was like something that when we were on the phone with Sysdig, that I was like, wait, did I hear that correctly? And they were like, yes, this is exactly what happens. Within the context of a container, we're able to dig down to the host kernel, grab those syscalls, map them with other arbitrary information, all through a dynamically loaded kernel module, thanks Sysdig, and then spit that back up to Falco, and then take it a step further and iterate on those and run them against rules and through a filter and actually figure out if anything weird is going on. So that's pretty cool. So here we have buffered outputs. I'm not going to go through and read all this. Looks like we have some bursts. We have syslog output. And you can go through and, if you wanted to tweak something very specifically to the Falco service itself, this would be the place to come in and do that. But we're going to go ahead and get out of here, and let's see what else we have. So we have Falco. Oh, this is going to be a tongue twister. Falco rules local YAML. Okay, so let's cat this thing out. Local.yaml. And I have a feeling this is going to be pretty big. No, it's not that big. Okay, so your custom rules go here. So if you wanted to come and start writing your own custom rules using the Falco rule engine, you could come do that here. And let's just see what this says. It says add new rules like this one. Okay, so we would say rule. The program sudo is run in a container. Description, an event will trigger every time you run sudo in a container. Condition, EVT type equals exe CVE. And it looks like there's like some interesting operators here, and container ID is not equal to host, and proc name is equal to sudo. So you can actually go and you can define a condition, which I think is like, this is just sort of like what happened. This is some sort of event. Like if this condition is meant to be true, then we do this output here, which is actually what the Falco logs would output, that then you could take and do whatever you want to with, which says sudo run in a container, and then it's going to give us our username and our container info, our proc name, and maybe the command line command that was actually typed. We're going to say this is a priority error, and we're going to give it a handful of tags that we can use for arbitrary reasons downstream later. So let's see if we can't find like the documentation on rules here. So if, I'm assuming that's going to be here in Falco. Let's actually go here, github.com, Falco Security Falco, and let's go to falco.org. And let's do docs. Falco rules. A Falco rules file is a YAML file containing 3 elements: rules, macros, and lists. So I think we just looked at a rules file. And yeah, here's what a rule is defined as. You give it a short, unique name, the condition that we just talked about, and I think these are all the different things you can define in a rule. And it looks like there's this filter syntax you can learn using the sysdig filter syntax, which, so okay, this is a sysdig level thing. So what I'm learning is if you want to be really fluent in Falco, you better also probably pick up a book on sysdig as well, because you're going to be like writing rules against sysdig filters as we start looking at various syscalls that are coming through our system. Okay, so I'm not going to go super deep into writing rules. I'm mostly just going to look at the ones that Falco ships with by default. So Mark Stem says, I added a link to the Falco wiki page you just found. Thank you, Mark. I really appreciate when folks do that. That's really helpful. Okay, so we can append lists, rules, and macros. And really quick, friends at Sysdig, what is the difference between a list, a rule, and a macro? Let's see if I can figure that out while we wait for the stream to ask you to see if you have a good answer for me. If you use multiple Falco rules, you might want to append new lines. Heptio says, this is George. I need to leave, but feel free to keep submitting links to the notes doc, and we'll continue first thing on Monday. Thanks for joining, George. Thanks for helping us out. It's always good. It's always great because I get to spend my Friday afternoons with George, and then I get to see him go home, and I'm like, okay, Nova, you only got like another hour before TGIK is done, and then we can start wrapping up for the week. So it's always really exciting. So let's see here. It looks like we have macros defined, conditions, rules. A rule is a node containing the following keys. And those are the keys we just looked at. So a macro, as noted above, macros provide a way. Where is it noted? I don't know. Provide a way to define common sub-portions of rules in a reusable way. Mark Stem says, list is the list of terms. Macro is a condition snippet that can be used in rules. Okay, I see. So a list is a list of various items, and a macro is a condition that can be reused in various different rules that you probably use often. So it's like, I'm kind of envisioning a macro like the function of conditions. Like it's a way of bundling it up, giving it a name, and then using it arbitrarily throughout other lists and through other rules. And Mark says rules match against events can contain list macros by reference. So yeah, I was exactly right. So there's just a macro is just a way of bundling up a commonly used condition or set of conditions so that you can use them in various rules. Okay, so that makes a lot of sense. So if you want to come through Falco, learn about these, feel free to come learn. And then also Falco, but the YAML that we're about to look at ships with a bunch of these already, so you can probably do a little bit of inferring and getting some context clues and maybe tweaking some and borrowing some ideas that the folks at Sysdig have already done for us. So let's look at some of those actually. So let's go back to our terminal, come in here, and let's cat out Falco rules.yaml. So this is the big one, yeah. Whoop, let's scroll all the way up. So there's a lot of rules in here. And look, it actually overflowed my terminal's buffer. So we're not even going to be able to look at all these. But that's OK, because there's going to be a lot here. And it looks like we have like definitions for like MySQL, OK? So if proc name starts with, or if the proc name is in start mysql.sh or run mysqld or proc pname equals start mysql.sh, and fd name starts with etc mysql, or I'm assuming fd is file descriptor directory is equal to etc myconf.d. Okay, so basically what I'm seeing here is a lot of these like proc, fd, there's another one here, proc pname. If you've ever looked at syscalls before, these are very familiar things. Or if you've ever done an strace before, you've probably seen these very special types of words. And I'm assuming this is just a type of an event coming off of a syscall that we can now trigger on. So basically it's saying like, hey, if there's a file descriptor that's open for etc my.conf.d, we're probably going to want to know about it. So this is the condition here. So you can come through and start writing a lot of these. And I just happen to know MySQL really well, so this kind of makes sense to me. But you could go through and maybe borrow this and set it up for you and your team's service or various other services that you might be interested in running. But it looks like we already have a lot here. Look, we have HTTPD, which is the Apache server, Redis, OpenVPN. Oh, we even have good old PHP handlers, good old pre-hypertext processing language, sed writing temp file. Oh, we even alert if somebody writes a temp file with sed. I want to see this now. Cron start switch, etc security sed. Okay, so if somebody starts setting our etc app sources list.d or conf.d, like we want to know about it. So that means they're mutating our repository information, which means they're changing where we're downloading things from, which means we might be accidentally downloading malicious tools without knowing about it. So it looks like they've gone through and done some pretty thorough rule writing for us, and we kind of get that for free. So this is pretty handy, and this is a really great way to start looking at your systems holistically and start building these filtering checks as you're monitoring your systems and as you're trying to detect anomalies in your systems. And if you look at writing these rules files, sort of like writing unit tests, the idea here is that the more of these you write, you sort of start to build this archive of them, and that archive becomes powerful and introduces confidence downstream. So like it may seem long today, but every time you write a rule, you're actually hardening your systems. You're making it easier for yourself and harder for attackers or malicious users to harm you or your systems along the way. Mark Stem says also added a link to the wiki page that names all the fields you can use. Okay, thank you, Mark Stem. So we're not going to spend a ton of time looking at these rules. But it looks like there is quite a few of them. And we're just going to sort of take their word for it and install these and see if we can't get some triggers going, or to trigger something just by doing some malicious things in a container downstream. And I'll probably just try for a few minutes, just like see if I can't get around it or something, or kick off an alert message, and we'll see if Falco can pick it up as I'm sort of being malicious later. And I don't want to give away, I don't want to spoil any of the secrets by looking too hard into what the rules are. I just want to see if they're going to pick up anything that I think would be relatively normal for somebody who is trying to be invasive to do. Okay, so let's get out of here and let's go back to our Falco documentation now. And let's see, where was that at? It was here. Okay, so that's basically what we're copying over with these two commands. And I already went and did that, and those are the files we looked at. And then it says if you want to come in here and you can change this program output. So this allows you to plug it into things like Slack. And if you look here, it's actually just doing a curl -d xpost. And it's just posting to the Slack API here. And I'm assuming, yeah, we have some sort of JQ text output. Excuse me. So we're formatting it and then just doing a curl. So you could pretty much post this anywhere that accepts a post request that you can format using curl and JQ or anything else you want. So you're able to build really exciting outputs here using just basic bash syntaxing. Okay. So the next step is we want to create this config map. So we're going to take all of that YAML we just looked at. So this is the configuration file for Falco, the local rules that you would go and define, and then the default rules that Falco has already set up for us. And we're going to bundle all of that up into a single config map. And we're going to do that with this command here. So let's do from config map, and let's go ahead and let's see, where are we? Print working directory. Go up here, and let's go ahead and run this create config map. Kate's with our back. There we go. Now let's try this. KubeCon will create config map. Config map Falco config created. So k get cm. And we can do an OYAML on that and actually see this is going to be huge, but we have all of the YAML we just looked at running up in Kubernetes now. So let's clear our screen. Okay, so now we have our config map up and running. And next, let's do KubeCon create -f Kate's with our back Falco daemon set config map.yaml. copy that, come here. Actually, let's look at this first. I want to make sure that we're not doing anything we don't want to do. So let's do cat cates with rback falco daemon set config map.yaml. Nope. Where do we want to go? Right here. So here's our cat. And API version, kind daemon set, it gives it a name. The app is called demo, which if we want to try to service, we're going to want to remember that downstream. We have a spec, it's going to have some labels, it's going to be called demo. It's going to map to our service account that we created earlier called Falco account. The first container we see here is going to be called Falco. It's Falco security, Falco latest. So this is just Falco running in a container. So you could actually do a Docker run on this or a Docker pull, and you could actually run this on your local file system if you wanted to try to get Falco up and running there. We're running in privilege mode, which is, I'm assuming that means we're running with elevated privileges. We're going to give it a handful of args, like our service account token that's going to come from var run secrets, and then we're going to mount various things onto the Falco container here. This is exciting. I didn't realize this was a thing, but we're actually mounting the Docker socket into the Falco container. That's pretty cool. If you're familiar with how Docker works, the Docker socket is like, it's like the equivalent of like the gates of hell to Docker. It's like this is the main thing you can interact with to totally mutate containers on your file system. So we're mounting that. So we're basically giving Falco here, not necessarily root, but we're giving it direct access to the Docker socket. And depending on how we have Docker set up, Falco might be able to do some interesting things. Let's see, interhub says, try to deploy the image into Kate's and it's failing. Interhub, maybe you could drop a little bit more information in the GitHub issue and throw the issue in our markdown file to see if anybody on the call with us today can check it out. Okay, so keep going down. We're running out of time, so I'm going to start speeding up just a little bit. We have some more volumes to find here. Here's our Docker socket again. We're going to grab /dev, /proc, /boot. We're even grabbing our module /user. Okay, so we're pretty much grabbing the entire Unix system. And if you're a Unix nerd like me, you see things like /proc and they're being mounted into a container, and you're kind of like, oh gosh, oh golly, that's a little bit scary. /proc is a very special directory in Unix. It's actually not even a real directory at all, and it contains really, really valuable information about all parts of your system, all the way down from the kernel, all the way up to user land. And depending on what you do in that directory, you have the possibility to really make some interesting and possibly vulnerable changes on your system just by like changing certain files and creating files and deleting files and changing values, like changing zeros to ones and stuff. So you can go through and read more about proc. It's pretty complicated, but it's just one of those things that if you're messing around in the proc directory, you better know what you're doing, and usually you're going to have a bad day. Okay, so /user, that's most of our configuration stuff, /boot, how our system's booting, and dev, all of our devices. So we get a lot of information coming into this container, and let's go ahead and let's get this up and running. So let's get our copy command here, kubectl create. Cool. Okay, Falco created. So now let's do a kget PO. Mark says we do mount most of that stuff read-only. Okay, Mark brings up a good point, which is that stuff is read-only, so we're not going to be able to make a lot of those changes. We're just going to read from it. Just giving folks mostly just things to think about, but good call for pointing that out, Mark. We do appreciate it. Okay, kget PO, no resources found. Let's see what's going on here. Let's make sure all of our nodes are working. Okay, so we have 2 ready nodes. So let's do kget. We know it's running as a daemon set, so we can do DS for short. Falco 0, available 0. What is going on here? Kdump grep defaults. Not kdump. That's how I feel today, though. Kdump. Okay, so we have a daemon set, and that's all we have. Why is that not creating any kEdit? What was the name of our daemon set? Kget ds. Falco k. Get ds Falco OYAML. Let's see what's going on here. Falco daemon set. What's our status? Current number scheduled, number ready 0. Why are we not scheduling? We have a node that's ready, but no pods. Did we skip a step maybe? Let's see what's going on here. So we did our RBAC. Let's just make sure we ran all this stuff. And then if not, we can go to my cheat sheet and see if there's a step I skipped or something else I added in there that... Okay, yeah, that was it. We didn't apply our RBAC. Okay, I see what's going on. Kernel dev headers. Nope, I think it was just I didn't actually install the RBAC. I only installed the config map. So let's try this now, or maybe still pulling. So now let's do kget daemon set, kget PO. Did we skip another step? If I skipped that one, I wonder if we also skipped... I'm pretty sure we did the config map. I remember doing this kubectl create config map. Yeah, because we looked at it afterwards. Let me restart this this daemon set and see what we can get here. So it was k applied -f daemon set. I can just do this k delete -f Kates with RBAC Falco daemon set and then let's do an apply again. Now that RBAC is in there. Kget ds. Yep, there we go. That did it. Up to date 1, desired 1, current 1. Okay, cool. So now I bet if we do a kget PO, yeah, there's our Falco pod. Okay, rad. So let's look at the Falco pod logs and see what's going on here. Earlier I had mentioned we're actually going to be able to see the dynamic kernel module loading. So let's see if we can try to find that. So we're going to do k logs, name of our pod, we'll do -f for good measure, and let's see what we have going on here. Okay, so it's setting up user source, it's unloading Falco probe, kernel preparation unnecessary for this kernel because I already did it earlier, but the kernel module is already loaded because I've already ran Falco on this cluster beforehand. But if it wasn't loaded, now it would use DKMS and do a dynamic kernel module load so that we can actually start parsing these syscalls. And it comes in and it like bootstraps itself, it checks, looks like we have a few errors here, but nothing too crazy to concern ourselves with, I don't think. Read-only file system, which is good. And it says trying to load a DKMS Falco probe if present. And it's loading our rules that we looked at earlier from the config map that have since been mounted into the pod. And now we're listening here on port 8765. Let's see. People are saying stuff in chat. Kernel dev headers, maybe still polling, describe the pod. Oh, Patrick joined. Patrick, yay. Patrick's one of my really good friends. I've known him for about 10 years. We work together, and I think this is the first time he's ever joined me on TGIK. Thanks, buddy. So anyway, Nicholas says taints and tolerations, maybe. Mark Stem says those errors are okay. Okay, thanks, Mark. Okay, so let's try to do something malicious and see what Falco does. Just out of the box. Let's see if Falco can detect me being invasive on a Kubernetes cluster. So let's open up a new terminal here. Let's zoom in here, here, and here. That's that Control-O, Control-P command again. It's really nice, right? Okay, so let's kget PO. Let's grab the name of our Falco pod. Patrick says, hola. Mark says you want to add Kate's audit rules.yaml to the config map to get the rules specifically for Kate's audit support. Did I not copy Kate's audit rules over? Where are those at? And we can get those here in a second whenever we do audit. I'm going to try to speed things up here because we're already an hour and 10 minutes into the episode. But I want to show Falco, and then if we can talk even just holistically about the dynamic auditing bit and how that works with Falco, we can do that a little bit at the end. So let's try to exec into this pod. So the documentation says even execing into the pod alone should be enough to trigger a Falco event. So let's go ahead and let's do kexec it Falco, and we'll just run bash in here. Bam. So I'll run list. I'm not going to do anything super invasive. Maybe I'll like come to var log, and let's oh, what's going on in dpackage? Cool, we grabbed all those logs. I'm going to go send them off and steal your credit card numbers now. Actually, no, but let's see if Falco is going to start. I'm wondering if it's going to start picking up any of the things I'm doing here. What if we go into Etsy and let's do something that is a little exciting. Let's mess with our FS tab. That could really screw things up. Let's see if we can't. Nano FS tab. Nano not found. What editors are on here? Is EE on here? Oh my god, is it VI? Vim? Okay, there's no text editors on here. We could use sed, but let's just look at FS tab. Unconfigured FS tab for base system. Mark Stem says no problem in the rules directory in GitHub. Okay, cool, thank you. Still not seeing any events here. Mark or Dan, any idea why we're not getting any logs here? Do I need to exit the container maybe? Let's see. I'm still not seeing anything. Let's try it again and see what happens. Let's go to proc. Let's cat at CPU info. This is relatively harmless. Okay, but at least now I'm getting information about our CPU. Let's see, can we get some C group information? What's going on here in C groups? Change directory C groups. Is that not a directory? I thought it was a directory. Let's cat that out and see what's going on. C groups. Okay, so we don't have very many defined. Okay, but regardless, I would kind of hope that Falco would say something's going on here. Let's maybe try to run a pod and see what happens. Let's run it in kube system and see if Falco, or I guess we're not configured for Kate's auditing yet. I still would really like it to detect me being malicious in a container, but I guess we can wait and see if anything just magically happens later. Okay, let's talk dynamic auditing really quick, and then we'll try to plug dynamic auditing into Falco now that we have Falco up and running. So to go to github.com, or sorry, kubernetes.io, let's do audit sync dynamic auditing. Nope. Kubernetes audit sync. See if we can't find anything here. Okay, here's auditing and audit policy. So there actually is an audit policy that's defined in the Falco example here. So there's a little bit of documentation on it. I think I added it here. Let's see if I can find it. Show notes. Maybe not. Either way. Let's go back. Where were we auditing? Is there an audit sync anywhere in here? That's what I want to talk about. Okay, so yeah, the audit backend is the audit sync API object. Is there an example of one of these? Here we go. Audit sync. Okay, this is what I want to look at. So these audit syncs are how you're able to use dynamic auditing, which is the new feature that Patrick here coded for us in Kubernetes 1.13.2. So Mark Stem says, cat etc shadow on the host first. Also the logs might be buffered by default. That's something you can change in the Falco config. Okay, so I think what Mark's is saying is like, let's do etc shadow on the host. So we can do that here in a second. And then also the logs might be buffered. So how would we, let's try to do the log buffering really quick. How do we turn log buffering off? So let's go here, change directory into Kate's with RBAC, change directory into Falco config, and let's do Falco rules, falco.yaml. And actually we'll edit it in this here so folks at home can see. Nice big text editor here. So let's see where that is. That's Kate's with RBAC, Falco config, falco.yaml. Let's just grep for buffering. Buffered outputs. Whether or not output to the output channels below is buffered. Let's set this to false. And let's apply that. So create config map. And let's change directory up here. And now we should be able to run that create config map. Kubernetes delete config map. Falco config. Not Kubernetes, K. K delete config, Falco config. Now let's create it. And I wonder, do we want to, let's just nuke that pod as well. K get PO. K delete PO. This thing, I don't think we should have to restart the daemon set, but if anybody thinks we do, drop it in chat and I'll do that as well. And let's get pods and see what's going on now. Oh, it's terminating because it's a daemon set. It's going to take a second. Okay, cool. So let's go back to auditing while that new pod, hopefully without buffered output, comes back to life. Also, where did my mouse go? There we go. Okay, cool. Okay, so an audit sync is one of many possible places where you can point Kubernetes dynamic auditing to. So I've already taken a little bit of trouble out of our hair here. And let's go and let's open up Golang, and I've written an audit sync here that should actually talk to the Falco pod as soon as we get the Falco pod IP address here. So to do that, let's get kget PO, wide, and let's grab, let me expand this so you can see. We're 192.168.1.5. So we'll do logs on this, and then we'll create our audit sync. So k logs follow. We can try to do an exec into a container in a second, but we're going to cat etc shadow anyway, and hopefully our logs are no longer being buffered. Let's apply our audit sync, and let's also actually open up a third terminal here so that we can look at the API server logs while we're doing all of this. Sorry if it's a little bit blown out for folks at home. I'm trying to show a lot on the screen at one time. Okay, so we'll clear that, let's do kget po namespace cube system. We want the API server, which is this. So then we want to do klogs, bam, namespace cube system. And we want to do -f. Cool. So then let's create our audit sync here. Audit sync.yaml. So we should be able to go to the TGIK directory and just apply that. Go source github.com, Heptio TGIK episode 61. And we should do k-apply -f audit sync.yaml. Audit sync created. So as that goes through, we should see some logs here in the API server. And we'll wait for that to point. Actually, we need to redo it because we're going to wait for that to point to the Falco server, but we need to change this to 192.168.5. And then we're sending this to port 8765, which is Falco's default port, and we're sending it to the Kate's audit endpoint. Now, I think this should be enough to actually just magically turn on Kubernetes auditing on the Falco side, but I'm wondering if folks, either Mark or Pop here, can let me know if they see anything that looks a little bit promiscuous here. Ashish suggests split terminal horizontally. I actually don't know how to do that off the top of my head, so we're just going to go with vertical for the time being. Sorry. And really all that we want is just to see if anything happens. Oh, cool. Okay, so here is our error and audit plugin, dynamic webhook affecting one audit event post. Okay, so let's re-update this thing really quick. So we want to k delete -f audit sync.yaml and k apply -f audit sync.yaml. Okay, so this should be going with the right IP address for our pod now. And if all goes well, we should see the API server here fix itself, and then hopefully we see like a little message here on the Falco side that says, yes, we have a new Kubernetes audit stream. Let's see, looks like we're getting more errors. Let's see what this one says. 192.168.2, Kate's audit timeout. Let's see. Stage response complete, method get kube system control manager. So Mark Sim says, it looks okay to me, although we have to make sure the right IPs are reachable, also adding the Kate's audit rules.yaml to the config map. Okay, so let's add the Kate's audit rules.yaml to the config map and then reload the config map and restart our pod. And I'm wondering what's going on here. These just look like controller manager plugins. Okay, so it looks like it's still reading error and audit plugin dynamic webhook. It's still trying to point to 192.168.1.2. So let's see here. Let's go back and let's fix our Kate's config YAML, and then hopefully by the time we do that, this will go in and fix itself with the new audit sync. And let's see if we get lucky. So first things first, let's close this one, clear it, get that out of our way, come here, and it's in the rules directory, said Mark. So go source, github.com, Falco security, Falco, and then is there rules? Yeah. So now let's copy Kate's audit rules to go source github.com, Heptio TGIK episode 61. What's in here? Kate's with RBAC, Falco config, and then we want to call this thing Kate's audit rules.yaml. Go back to our last directory, and then let's redo our config map again. So k get config map, k delete config map, Falco config deleted, and let's do our create command again. I think we had it here, I want to say. Kubectl, yeah, it's that one. I know it's hard to read, but we just created it way over here on this tiny terminal. And we can actually probably close this one and make it a little bit easier now. Okay, so the config map has been created. Let's restart our pod again. So here's our pod, k delete po, bam. Let that delete and resync itself. And now let's see what the API server logs are doing. K get po, namespace kube system, kube API server. And I think we're probably going to have to update this thing again because we're going to get a new IP address after we updated our config map and had to restart our pod, but we'll see. Herman says, YAML or YAML, I'm always wondering. I have no idea, Herman. I think it's, the spec calls it YAML, Y-A-M-L. It's yet another or YAML ain't markup language. And you can go read the spec. And actually, I learned a little bit about the YAML spec when I was reading through the Falco docs. I never knew that a section of YAML was referred to as a node before. But yeah, that's technically called a node. Kube API server, so let's do logs. K-logs, kube API server, namespace, kube system, -f. So here's an audit event, so that's exciting. Response complete. Let's see what's going on here. And we'll get get PO. We'll do O wide. Now it's 1.6, so let's go and change this. Here in our audit sync, 1.6, save that. And let's delete, or actually get audit sync, delete audit sync TGI K apply -f audit sync YAML created. Okay, and let's see if our logs here get it. And then while we're going to watch the API server logs, let's also watch the logs for Falco here to see if we see anything about it, recognizing that there's a new data stream coming in. If everything worked, we'll see if we can get this thing to work or not. So get PO. Ooh, crash loop back off. What's going on here? Describe PO. Bam. Back off restarting container. Let's scoot this over, see what's happening. Config map. I wonder if I messed up something in the config map and now it's in crash loop back off. I don't see any, I see a warning. I don't see any errors down here. Let's see if we can't get logs on this thing. Get PO. Logs, bam. DKMS install completed, trying to load a DKMS Falco probe. Falco probe looked in DKMS. Invalid output from Kate's operation performed by user not allowed in list users. Any idea what this is telling us, Mark or Pop? Runtime error. List of users, user, username, target name, verb. Operation performed by user not allowed in list of users. Container ID, filter check, Kate's pod name, container exiting. I don't really understand what this error is saying, but it looks like it's some sort of permission error that we're trying to do something that isn't allowed. This, to me, smells like something in our config map that we just updated is now preventing our pod from starting. Wondering if this is a common error that we know the answer to or if we need to dig deeper. So I'm going to grab some Diet Coke while we see if they have an answer for us. And let's check our audit or API server, not the audit logs, but the audit logs, the logs on auditing, not the audit logs themselves, to see if we have anything in here. So it's still going to 192.168.1.2. Never seen this happen before, but interesting behavior here for sure. Mark Stem says, yeah, 1 sec. So it looks like Mark is getting on it. Okay, so while we're waiting for Mark, Patrick, if you have any ideas what's going on here in the API server bit and why we're still looking at 192.168.1.2, let me know. And I'm going to start to kind of wrap up because we're already an hour and almost 30 minutes into the episode. And I want to see if folks have any questions or anything at home. Mark Stem says, it's a bug we haven't fixed in 0.13.0. In the command line for Falco, dropped the PC argument in the daemon set. Okay, so it's a bug. Let's see here. We can fix this, no big deal. Okay, so we want to go to the daemon set. Sorry, the PK argument. Yep, 1 second, Mark, and I'll add that in there. So here's our daemon set. For the Falco command line, user bin Falco K. So we want, what do we want to add? We want to add PK. Can I just add that here? Can I do that? I'm going to wait for you to say yes or no before I push this thing. Because if we can just do that, I can just push it and then we can see if that's going to do the trick for us or not. Waiting for the internet to buffer. So yeah, there's always like this 20 or 30 second lag behind what I say and what you hear. So like actually you're watching about 30 seconds like old Nova, which is exciting. It's like I'm on the other side of the universe or something. You're like seeing me from the past. So anyway, waiting for Mark, and I guess just to high level really quick everything that we've kind of talked about, and then to talk about what we're trying to do here at the end. Mark says, no, there's a -pk argument already, remove that arg. There's a -pk argument already, remove that arg. There's k, oh, -pk here at the end. Should be at the end of the line. Drop the pk. There we go. Okay, cool. So I'm going to run this now. I keep trying to high level everything, but then just as I'm like, all right, let's high level it, and then Mark says something, and then I want to go try it. So let's see here. So now we have our k-get daemon set. Let's delete Falco, k, delete daemon set Falco. That's deleted, and now we want to do k apply -f. Where are we? Kate's with RBAC. Falco daemon set config map dot YAML that we just removed the -pk at the end. Okay, so that was created. K-get PO. Yay, it's running and it's 4 seconds old. K logs, bam, -f. Starting internal web server, listening on port 8765. This is still on 192.168.2. Interesting. I wonder if we need to like restart the API server. Let's try that. K-get PO namespace kube system. Don't ever do what I'm about to do at home. I have crazy ideas that I think it's a good idea to just restart stuff in kube system. Please, please, please don't do this at home. But this is just for a demo. Let's go ahead and restart the API server. I mean, it'll fix itself and it should be fine. It's not a big deal, but just in general, like be careful in the kube system namespace, please. Okay, so kube API server, k delete PO, this thing, namespace kube system, and k-get PO, namespace kube system. Kube API server is pending, k logs, this thing, -f, namespace kube system. Let's see what this does. More audit logs, 192.168.1.2. Interesting. I don't know why we're still getting 192.168.1.2 here. K-get audit sync. Bash OYAML. Yeah, it's defined as 192.168.16, or yeah, 192.168.16. Interesting. This should be working. I don't know what's going on here. It should be at the end of the line. Okay, rad. That's chat from earlier. Okay, so let's just keep these logs up and we'll wrap up the episode. Actually, you know what I want to do now is I want to see if that buffering flag worked. If we were able to flip that to false, if we're actually able to get some logs here now. So let's k-exec. We're gonna exec back into this pod and see what happens. Bash. Bam. Okay, so that was really quick. Okay, so we got the buffering turned off. So Falco is working. So let's just see like. If I cat etc shadow, is that not in here? Yeah, it is. Bam, so we got like a lot of logs over here. Notice a shell was spawned in a container with attached terminal, writing sensitive file. Okay, so Falco is really lightning quick, and then you can take these logs and you can like, have various outputs, you can hook it up to other things. It's basically like an event system at this point, and you're able to actually start detecting things on your system. So that was really exciting. So Ashish says, do you have more than one API server? How is API server pending and you're still able to run kubectl commands? That's a really good question. Ashish, k-get PO, namespace, kube system. Oh my gosh, I'm in the container. K-get PO, namespace, kube system. Kube API server, we only have this one, it looks like. I'm wondering if I just go and restart kill the pod on the host and then Kubernetes reschedule. I don't know. This is just really weird behavior. I'm not an API server expert. A lot of times the assumptions I make about Kubernetes are wrong off the cuff for very important reasons. So I really don't know what's going on here with the API server and why we're able to restart it and still make kubectl commands and it was still in state pending. Seems interesting. Christopher says there should be a new Falco pod IP address after the DS was created. Christopher brings up a good point, which I'm sure there is, but regardless, it doesn't look like the API server is respecting our audit sync stuff anyway. So maybe we can try a new audit sync and see if it kicks off something else and we get a second one, or who knows what's going on. So let's do this. So let's get our pod IP address, kget POOY. So this is now 1.7, and this is for our Falco pod. This is an odd bug. I'm going to file this. Thanks, Padillac. So let's go to Goland. Let's go back here. So where is our audit sync? Here, 1.7. And then let's actually do this. Let's do TGIK2, stages response complete. So now let's try to create a second audit sync and see what happens. K apply -f audit sync.yaml. Okay, so that was created. K get audit sync. Oh, sorry, no dash. Audit sync. So now we have 2, and let's get those API server logs again. K logs API server. Mark Stem says, I haven't used the audit sync much. I see you did delete it and recreate it though. Typo 76. Oh, thank you. I typoed 76. Let's see. Right here. Derp. Good call. Who was that? Hamid. Free stickers for you, Hamid, for catching that one. So let's try this thing again. So let's actually, you know what, for good measure, let's just see if we can't create a lot of these things. TGIK3. Okay, so now let's do our apply again. Audit sync.yaml. Okay, so that was created. So now get audit sync. We have 3, and now let's grab those logs. Let's see, get some space. 192.168.2 again. Wonder if we can just create pods and IPAM will eventually recycle, and we'll get 192.168.2 again. So here's a 1.2. Let's see what else we got. More auditing events. Nothing new in Falco. Okay. We'll let this thing run. I'll keep it pulled up. Folks at home can look at it as it's running. Unsure what's going on here. It looks like we're filing bugs. It's an alpha feature, so maybe we can try this again in the future. But already I feel like folks are getting a really good idea of how dynamic auditing is supposed to work with the Kubernetes audit functionality. Patrick says, I would try resetting the container on the master. And Christoph says, API server pod should be running as a static pod, which is not controlled by Kubernetes directly. Maybe that's why it did not it did not affect the cluster. That is a good point, because the Kubernetes API server, it's not. I don't think it runs as like a deployment or anything. It's just a static pod, which I know there's some really weird, interesting behavior there. And that's sort of built in there for resiliency reasons for the API server. So maybe there's something else going on there. Mark Stem, is that question mark timeout 30 seconds really in the post? Unsure what you're talking about, Mark. Oh, here. He's talking about this post. 192.168.1.2. Kate's audit timeout equals 30 seconds. Context deadline exceeded. Client timeout exceeded while awaiting headers. I don't think so. I don't know what the API server is doing with an audit sync configuration after we get it. It might be doing something a little bit weird. But yeah. Let's high level this thing really quick and we'll get out of here. It's already an hour and 30 minutes in, and I think we've done enough. We've looked at Falco. We understand the ins and outs of Falcos, the intricacies of getting the syscalls, building those together, and then getting a rule parsing engine that we call Falco on top of all that. And we'll kind of go through all that here in a second. And if folks have questions, now's a good time, and I'm going to go back to my face, and we're going to wrap up the episode here. Okay, so we were able to get Kubernetes 1.13 up and running with kubeadmin using the kubeadmin config that I have here locally, or it's actually in my GitHub branch, but we'll merge that into the Heptio TGIK repository. So if you want to replicate what I did here today on your end, this is a really good config, and you'll be able to build a cluster exactly like what I have with KubeCon. So after you have the 113.2 cluster up and running, you're going to want to make sure you have those API server flags also enabled if you want to use dynamic auditing. So after you get, let's see, Hamid says, which track are you presenting in FOSDEM? Hamid, so I am presenting, I'm doing a Kubernetes with Kubeflow and a few other things for the ML track with Holden Caro. And I'm also doing Kubernetes, it's another, I'll say cluster bleep because we're on TGIK, but it's another one of my really exciting deep dives into the Go programming languages with Kubernetes, and it talks about a lot of the weird anomalies in the Kubernetes source code and how we got there and how we're like coming up with really clever refactoring techniques to like sort of pull ourselves out of these corners that we've painted ourselves into. So it's a really awesome talk about Go, how you can structure your code in Go, what to watch out for, anti-patterns, patterns that start out as regular patterns that turn into anti-patterns, and then advanced refactoring techniques and some of the stuff we do in Kubernetes, which is really exciting for anybody either who works in Kubernetes or has a lot of Go code that they're trying to refactor and trying to get themselves out of some sticky situations. So those are the two talks I'm doing. Okay, so thanks to our friends at Heptio and our pal Nova. Thank you, Pop. Very nice to meet you. And again, thanks for all your help. Mark, especially you. You've been super helpful today. And let's go back and talk about what we were able to do today. Okay, so I explained how we got the Kubernetes 1.13 cluster up and running. So now the API server was configured with the API server flags, and we were able to actually go and create an audit sync object, and then the API server looks like it's trying to reconcile it based on what you define in the audit sync, and then it will start sending dynamically Kubernetes audit streams to whatever client you configured. So Falco has built-in functionality that allows us to point the Kubernetes audit stream at Falco, and Falco is able to parse the Kubernetes audit streams with various rules. So those are those Kate's rules.yaml that we added at the very end to the config map. So I know that the engineers at Falco actually spent some time building very specific custom Kubernetes functionality that allows us to do a lot of interesting rule parsing on top of the Kubernetes audit rules. Furthermore, Falco is built on Sysdig, which, like we said earlier, is like TCP dump or Wireshark for syscalls on your host system. We mount read-only some volumes into the Kubernetes pod, and then we're able to take advantage of the dynamically loaded kernel module that Sysdig gives us, and we're able to start parsing those syscalls for anomalous behavior, and we're able to make sense of them. And so that's where Falco comes into play. And so we can glue all that together by pointing a dynamically configured audit stream at Falco. Falco is able to take that and we can write rules against it. And if one of those conditions trips, we flip one of our rules and we get a log here in the log file. And we can actually pipe that to pretty much anywhere because we can write any bash command we want there as well. So Falco's flexible, and I'm already getting ideas of like the domino effect here. Like, well, what if we took Kubernetes audit streams, piped those into Falco, took Falco and like sent that up to like something like say like Prometheus or something that can generate alerts, and then we can have like different people get alerted for different things, and Falco can help us make sense of all this, and we can even bundle in like syscall level alerts as well. So we can really start to gain some confidence in our systems and confidence that our systems aren't doing anything we don't want them to do. Okay, so that's sort of the Falco plus dynamic auditing in a nutshell. It looks like some folks had some other comments in the chat. Marco says, great stream, thanks. Sadly missed some of it. I was a bit tired, but we'll definitely catch up. No problem, Marco. Also, Marco, I saw your Slack. I'm not ignoring you. I've just been really crazy busy this week. I promise I'll get back to you soon, Marco. Hamid, thanks for the demo. Mark says, I added a link to my KubeCon 2018 talk where I described the Kate's audit support in more detail, and I have a demo at the end. Awesome, Mark. So I think that demo is going to be not using the dynamic audit stuff that we looked at today, but the regular Kubernetes auditing that you can just turn on by flipping Kubernetes API server flags and restarting the API server manually. Peter Benjamin says, awesome work, Kris. Thanks so much for Sysdig Falco demo. No problem, folks. I love doing this. I love spending my Friday afternoons with the internet as we hack on things and try to figure out how to make Kubernetes and all these crazy new tools that are coming out of the cloud native ecosystem work. It's always a ton of fun. I'll do last call for questions, and then if not, I'm going to get out of here. I've got exciting plans tonight, and I think, like I said earlier, I'm going to maybe head down to Portland. We got to go check the weather and see how the weather on Old Mount Hood is doing, and I might fly down to Portland and go free solo up the south side, maybe even do the Devil's Kitchen head wall by myself. We'll see what weather says, and we'll see what conditions are. It's supposed to be pretty icy and it's supposed to be really cold, which is good. Maybe we'll get some of that nice styrofoam ice that we like to climb in so much. Awesome, cool. Well, it doesn't look like we have any questions. Dan Pop says, Sysdig Secure can do the alerts as well, and Workflow Falco violation to alert. Elysiano says, thanks, Kris. Great stuff as usual. No problem, Elysiano. Sorry we didn't do a giveaway this week. We'll get back into doing the giveaways, and I think we're working hard behind the scenes figuring out ways we can spice up TGIK and ultimately get some VMware products up in here, and maybe get some folks from the VMware side of things to come in and join us here in the Heptio studios and do like some live demos and learn more about those. So stay tuned. We have an exciting year in front of us. I have a feeling I'll be back next week. There's a good chance it might be Joe, though. But again, as per usual, hit me up. Actually, wait, no. We have next week, we're out all week for our VMware orientation. So I don't know if we'll have one next week. Follow my Twitter, follow Joe's Twitter, follow the Heptio Twitter, and we'll let you know if we have one or not. If you have any ideas, if there's anything you want to see, we mentioned Spinnaker earlier. There's that whole GitHub repo, github.com/heptio/tgik. Go into the issue tracker, drop your ideas. We're happy to look at them. Who knows what we'll pick? It's always a surprise to me every week when we pick one. Ashish, thank you so much for your help today, Ashish. Next time, and yeah, I'm out of here. So everybody have a good day, great weekend, and I'm going to go climb the mountain. See everybody when I see you.